Good afternoon, students. In this part of the video, we will do the remaining portions of chapter 2b. So let's just go through the graphs, okay? First of all, I have jotted down, see, the different kinds of graphs and what are the conditions, and under those conditions, the graphs of S, T, V, T, A, T. S stands for displacement, V stands for velocity, A stands for acceleration, okay? See, the first case, body is stationary. That means it's not moving. Do you remember that? What will be the displacement ST graph? Straight line parallel to x-axis. Now, velocity is 0 if it is stationary. So see, it's just like this. Time increases but velocity 0 as the body is stationary. Acceleration also. Now, body is moving with uniform velocity. That means displacement is changing but equal changes in displacement in equal intervals of time. So, moving with uniform velocity. Uniform velocity, that means for velocity time graph, this is for ST graph. VT graph, how does it look? Parallel to t-axis because V is constant. AT graph, again like this. Why? Because no change in velocity, so acceleration is 0. Next, body moving with non-uniform velocity, that means, I hope you remember this graph, velocity is changing but changing uniformly, that means uniform acceleration. So ST graph like this, VT graph like this, and AT graph parallel to t-axis. Why? Because uniform acceleration now. Okay. Body moving with non-uniform velocity but uniform retardation. It was uniform acceleration, positive slope, uniform retardation, negative slope. Retardation, so acceleration increases in, you see always this, we actually keep the values of the, say, in this case if you have written velocity, so basically this is a y-axis, this is the positive side of y-axis, that means the values are in the increasing order, say plus 2, plus 3, plus 4 and downwards minus. So retardation, it will have minus certain value but parallel to t-axis because uniform retardation. And one more thing, non-uniform acceleration is excluded from your syllabus. Okay, so you have cases for uniform acceleration and retardation. Okay, again see body moving with, it's just the negative slope of displacement I have shown. That means, say negative slope, that means you're getting minus something as velocity because slope is negative. So as the displacement, it's actually the body is moving towards the origin. So V will be something minus, say minus 50, minus 20 meter per second, whatever. And I hope you all remember that all this S displacements are in meter, time in seconds, and V meter per second, A meter per second square. And just remember this, that the sign of acceleration denotes the increase or decrease in velocity. Increase in velocity, acceleration, decrease in velocity, retardation. But sign of velocity denotes the direction of motion. And from displacement ST graph, we get, from the slope of ST graphs, we get velocity. From the slope of velocity time graphs, VT graphs, we get acceleration. Okay? And what do we get from velocity time graph? One more thing. Area enclosed between the velocity time sketch and the time axis. Area, this area. In this case, area of triangle. So it depends on the numericals which you will get. Okay, and also this type of questions comes, you have to draw the graph, condition will be given to you and you will have to draw the graphs as per the conditions given. And also you will get numericals, say you get a velocity time graph and you have to find the displacement or acceleration. You can find Just remember this important points. Now coming to the last topic, which is motion under gravity. What does it means? Body is falling freely under gravity. That means no other forces are acting on the body. We assume there is no friction of air, nothing. It's falling freely under gravity. So what is the acceleration due to gravity we consider? 9.8 meter per second square. We have learned this in chapter 2a, right? And which nearly we take it as 10 meter per second square while doing the numericals. Now when the body is falling from a certain height, at the topmost height, what is the velocity? 0. And as it falls down with uniform acceleration, the velocity, it keeps increasing. These are the different graphs for this motion under gravity. Graphs for acceleration, AT, VT and ST. See, first see this one. Acceleration time graph, what will it be? Constant acceleration, so, and positive 10 meter per second square constant. Throughout the time it is constant. Say the body reached the ground after 4 seconds has covered, the body has reached the ground. So G is constant throughout. Now just see, can I make the table like this? This is the entire table, but let's go one by one. T equal to 0, G 0. Sorry, this will be, this will be 10, okay? So, if for all the values it's 10, now let's calculate V, 0. Why? How do we find velocity from acceleration time graph? How can we find? Simply by finding the area enclosed, just like from the displacement time graph, from the velocity time graph, we got the displacement. How? By finding the area enclosed by the velocity time sketch and the time axis. Just try to remember this thing. Velocity into time gives us displacement, right? V into t is displacement. So, from velocity time graph, area under the curve will be displacement. From how do we get velocity? We get velocity by A into t is velocity. Just see, if velocity is change in displacement by time, so displacement will be V into t. That's why from VT graph, we get the area under the curve as the displacement. If acceleration is a change in velocity by time, then how will we get velocity? A into t. That means same, area under the curve will give me the velocity. See, one by one I'll just find it out, or simply here you can actually multiply. But just try to picturize the graphs. At t equal to 1, this will be the area covered. T equal to 1, don't consider the remaining part. So, 1 into 10 will be 10. See, velocity is 10. T equal to 2, that means up to this part, the area covered. It's a rectangle. 2 into 10, 20. So like this, we have got the velocities. And see, we find it's a uniform, velocities are changing but uniformly. See, 10, 10, 10, 10 in each second. So, we got the graph. Now, displacement, how will we get? Again, see, from velocity time graph, t equal to 0, we say s equal to 0, t equal to 1, up to this part, area half ABC. Why? Because this part is the graph, t equal to 1, that means still this. The curve, velocity time curve and time axis. So only this much area. Half into base into height, simply just find the area of the triangle. So like this, we have got 5, t equal to 2, CP, this one. Can you see this, the triangle formed CP and t equal to 2 in the time axis. Half into 2 into 20. Because it's basically half into base into height. So, just find now. Okay. So just like that, we have found the different values, and see, displacement is not changing uniformly, not equal changes in equal interval of time. So basically we are getting this graph then. So just remember learn how these graphs are coming, these different graphs. Go through the portions in the books and see if you have any difficulty. This was all about the motion under gravity and the different graphs.